Yeah. Hey everybody. Hello. Hello. Well, I hope you guys are enjoying your Portuguese and your various assortment of Texas beers, and soda and water. And actually, I don't know if you guys know this, but it's actually a tradition that loose tradition. We don't always stick here today, but since the very beginning of all for British years ago, we've almost exclusively served only Texas beer. So we're happy to be able to continue that tradition on. Right? Thanks to our awesome sponsors, Capricorn Security. And Capricorn Security is, we can see the right up here, but you're going to get to hear just a brief bit of information about them, and then let's go ahead and get started with our program. So everybody, please round of applause for our awesome sponsors.
Yeah, so I promise I won't take up much of your time. We're allotted more time than we would ever need. But we did want to come and at least talk a little bit about our company and let people know who we are. So we're Capricorn Security. There's a handful of us over here. Raise your hands. There you go. Those people. So we're mostly a cybersecurity R&D shop that moved down from DC about 6 months ago. We're a little over 3.5 years old. Primarily, we do services contracts for the government, doing R&D type cybersecurity work. But additionally, we have a couple of products that have fallen out of R&D we've done that we're starting to really recruit developers for and try and build teams around to bring. So we thought it'd be cool to talk about one of our recent products, and then maybe a little bit about some of the things we're hoping to do. So recently, we've been working on a product called Tachyon. Tachyon is a device provisioning and kitting solution for Samsung phones and tablets, I guess. But basically, there's this problem in enterprise right now where if you're a big company and you want to deploy a whole bunch of Samsung devices to your enterprise, you need to get all of them into the right state before you can hand them to your users. And this seems really trivial, but it actually takes 45 minutes to an hour a lot of times to install all the right applications, change the right settings, log into the right emails, all that kind of stuff. And that's really expensive in terms of time and cost. So Tachyon is a solution that we developed with Samsung to actually over the air allow configuration of Android. So it's an application you load up, you log in, and then Tachyon basically takes over your phone and can install applications, log into applications, change your Wi-Fi information, change your background, rearrange your home page, whatever you as the IT administrator want the state of the phone to be in, verify all this stuff and report it back to the IT administrator. It's really helpful in enterprise sense. But it's also just a cool product from a technology point of view because there aren't very many Android products, but we're hoping no other Android products, that can take over your phone and do these kinds of configurations that would normally take a person doing by. So on that same kind of note, we're looking to make a couple of hires to help support out the Tachyon piece. Right now, we're in desperate need of a really great web designer who also happens to be a JavaScript star. I think everyone would probably hire that person, but it's worth mentioning that we would love to hire them too. Additionally, we, as I mentioned, are mostly an R&D shop. We have a bunch of really smart cybersecurity R&D guys. And we started bringing on some new backend hires and working through our backend. But we're definitely interested in someone with a lot of backend design experience that's kind of gone through the whole life cycle a couple of times, and can maybe help us see some of the pitfalls that are coming down the road and how we can adjust them. So, I'll get into here. We're going to the bar with everyone afterwards. If you come find a Capricorn person, we'd be happy to buy you a drink, talk to you for a little bit. So, thanks.
All right, well, thank you to Capricorn. Every once in a while, we'll do, it's actually been a while since we've had a couple of meetups. So we usually off this will be the fourth Thursday of every month, usually off in November, December. And we happen to be off with drink ups and meetups in January as well. So it's our first meetup for a while, but we usually do time to time a 30-minute meetup. So if you guys are interested in something like that, we can definitely set something up. So, all right, well, thank you to Capricorn. We're going to allow we'll do 10 minutes of meetup. So we'll do 45 minutes of meetup. So we'll do 45 minutes of meetup. interesting Python news segment. If there's anything like current events or anything like that that people know of. And I wasn't planning on doing this, but this guy in the back over here with the plaid shirt and the beer and the smile, which I just probably described like half the people. He has something like he really wants to tell the
So just being a jerk, but I was talking to somebody random today about a library. Now I forgot the name of the library.
Cashelot?
Appreciate it.
Cashelot.
Django Cashelot. And the developer was actually like trying to put out the word that he's put out a bounty for bugs. Want to make it easy, $50 to go check out Django Cashelot on GitHub, find a bug that's reproducible. It's actually £30. So I think they'll do us. But that, and then in all seriousness, we have Django Time. We got like 6 months registration information, which should be coming up soon for that.
Where is that?
That is Labor Day weekend here in Austin.
You're not.
So that should be a big deal for us. And then we're still trying to figure out what that means for PyTexts and how that works together. But we should be spinning up soon on that. So if anybody's interested in volunteering for PyTexts, which will be in about 6 months, please come talk to me. It's making
You mentioned DjangoCon. If anyone is in sponsoring or assisting with the organization of DjangoCon, please come talk to me. We just nailed down the venue at the Incubator Center. And I'm looking forward to getting sponsorship built up and getting the college proposal back.
Yeah, that's a really huge deal that it's here this year.
It's going to be here for 2 years, maybe, right?
Yeah, they usually do 2 year blocks. That's 2 years if nobody has an excuse. All right, well, I will not ramble on any longer in my jokes, but I'm going to introduce Anthony. Anthony's going to talk to us today about a topic that's actually come up a lot, that, just sort of talking to people and on the mailing list about people wanting to learn more about MongoDB and how to use it with Python, how to integrate it with their Python applications, especially coordinate a lot of people might be familiar with Django and the focus on relational databases. So it might be interesting to hear a little bit about platform databases. So I'll let Anthony take it here. Everybody give a round of applause.
Thanks, Joe. Well, as Joe said, just a quick introduction for myself so you guys know who I am, what I do. My name is Anthony Dodd. I actually work at Rackspace right now. I'm with the Object Rocket business unit. And what we do there, among other things, we host MongoDB. We do MongoDB as a service. You guys need to come to us for any sort of MongoDB needs. That's really our target. That's what we do. I've actually only been working there for a little over a year. I think December was my 1 year mark. So I've been working there, very high skill environment. It's a lot of fun. I've been doing Python for, I'm gonna say close to 5 years now. Give or take a couple months, something like that. Let's see. Just before we jump any further into the presentation, I wanted to say I'm using slides.com. If you guys want to check it out, like if you are having trouble seeing one of the screens, go to slides.com/thedod with DD. That's my GitHub handle. And then it's going to be /Python and MongoDB. I can separate it, and then /live. So if you can remember that, you can see it up close. And also something I'm kind of experimenting with if you guys want to help me out. If you go to my GitHub public profile, it's the Dodd. I have a repo called presentations. If you like this presentation or you think it has value, give me a star, and that will kind of help me out in trying to publicize some of this stuff as well. So if you can do that, that would be super awesome. So just a little bit about the presentation before we jump all the way into it. Basically what I want to cover, you probably saw some of it when you were looking at the AWPUG homepage, but I just want to give kind of a high-level overview on what MongoDB is, how you would use it, kind of compare and contrast with other relational databases, things of that nature. I'm also big into ops, the DevOps culture, stuff like that. So we'll take a look at, kind of how to run MongoDB if you have to run it yourself, if you have to run it for just development purposes, things of that nature. And then obviously we don't want to leave out the Python part, so we're going to take a look at PyMongo, which is like the primary library that you would use for interfacing with MongoDB using Python. And then basically the last thing that I want to focus on is unit testing. I'm a big fan of testing. I think it's extremely important, so that's going to be something that I'll try to focus on. Depending on how everything goes, we might actually write some test code, but we'll see how much of this beer I actually drink. I might jump into another one before the presentation's over. No, I'm just kidding. I want that. But anyway, let's jump right into it. So this application works for me. So what is MongoDB? MongoDB obviously is a way of storing structured data. I'm going to harp on this quite a bit tonight because this has been one of my biggest frustrations with working with MongoDB, primarily with working with other people that are working with MongoDB, is this first item right here, flexible schema. It's not the same as schema lists. So the important thing to notice here is that if you're using anything like other relational databases, schemas are enforced on. I'm sorry. Oh, yeah, that's interesting. Sorry about that, guys.
Slides.com's work.
Technical difficulties.
So it came back up here, so.
Oh, you know what? You might be able to plug it in and it will keep it from
There
powering
it
on.
goes, there it goes. Should we just like-
Yeah, we can do that. Joe's gonna hack my computer real quick. We could probably just set those to never. Yeah, I'll configure it later. Hopefully that'll do it. All right, sorry, back to it. So anyway, I was saying, so if you're using other relational databases, schemas aren't enforced on the database level, like on the table level. You try to insert some data, it doesn't conform to the schema. This is stuff everybody knows. That's enforced on the database level. With MongoDB, there's nothing of that nature. It doesn't try to enforce a schema. It leaves that entirely up to you and to your application needs. So this has been probably the biggest frustration that I've encountered when working with MongoDB is that people are like, oh, well, it's schemaless, so I can just do whatever the hell I want to, but that's a really big problem. If you try, like, one of the things that I mentioned here is that this isn't just an object store. We're not storing like images and binary data and stuff, so you could do that. That's not the primary purpose of MongoDB. So if you're actually wanting to, make your life easy and be able to come back after a year or, maintain it throughout, maintain an application throughout a year's worth of time, even just a small amount of time like that, you're gonna run into data migrations. You're gonna wanna change your schema, add new stuff, so we're going to look at in the later part of the presentation some things that you can do to manage your schemas because Mongo doesn't do that for you. So it's very flexible and it is a cool feature of Mongo, but don't make the mistake in thinking that you don't have to worry about a schema. If there's one thing that you take away from that meeting, this is the one thing to focus on. So also, let's see. Okay, so just to basically give kind of a comparison to a relational database. With relational databases, something like MySQL, whatever, you have tables, right? And the tables is where you store your data. This is essentially equivalent to a MongoDB collection. And the equivalent of a relational table entry, it's basically a row of data, that's going to be a Mongo document. So collections in Mongo are like tables, and everything inside of that collection is going to be a document. It looks exactly like a JavaScript object. That's essentially what it is. It's stored in the database using some other stuff. I think they call it BSON. So it's slightly different in the way that's stored, but that's essentially how that works. Oh, no. All right, so let's take a look at some of the core components of Mongo. So this is kind of more along the lines of, operationally speaking, how you would run Mongo, how you would use it. So the MongoD, if you were to just, if you're using your OS X platform and you say brew, install MongoDB, whatever, you're going to end up having a few different binaries under that. MongoD is really the workhorse of everything Mongo. It's what actually runs the daemon process where that data is going to be written to and stored. And so it's probably the most important piece of the entire Mongo system. It can be run, MongoD, you can just invoke it, and it can be run as a standalone instance, per se. You can create multiple databases inside of it, but it can be run in a standalone mode. It can also be run in combination with other MongoDBs, maybe on the same box. Typically, you're actually going to run these on multiple servers, and this is what in the Mongo world they call replication. So what you do is you end up clustering Mongo so that you have the primary MongoDB that information is written to, and then it will replicate that information to the other nodes. So that if the primary node goes down, it holds an election and you're able to withstand certain faults in your environment. Let's see. Also, the MongoD can be used as a configuration server when you're sharding, which we'll take a look at in a second. And so when you see people in the Mongo community referring to something called a Mongo C, they're just calling them, they're referring to a MongoD running in configuration mode for configuring shards. So the Mongo S is another one of the core pieces of Mongo. The Mongo S is basically a router. So what it does is it's used when you're dealing with a series of replica sets and you want to be able to horizontally scale your data instead of just, we have too much data in our node, so we need to migrate it over to a larger computer, or a computer that has more disk. Obviously, you can only go so far with that. So what Mongoose allows you to do is to horizontally shard your data. And so the Mongoose is basically the way that this works, and I have some diagrams that I actually pulled directly from MongoDB's documentation. But what you can see here in the blue, you have the Mongoose routers, and they all, no matter how many Mongooses you're using, they all use the same configuration servers, just so that they can coordinate where information is being sharded and chunked to, which replica set it's sent to. And so when, for example, a write comes in, you're attempting to write information to your database, it's actually going to go to one of these Mongooses, and it will determine which replica set it needs to be written to. And also when you're querying data, it's able to figure out where that information actually exists so that it queries the appropriate replica set. So I'm not sure if there's a lot of ops experts in here, but we won't go any further into that because that can get a little heady. So the way that data sharding works is it works on the collection level. It's not something that you just get by default. It's something that you have to configure, and you have to configure for each collection. Once again, this is like a table. So collections are essentially tantamount to a table in the relational world. Also, when you're sharding your data, you have to select a shard key. So this is basically a way of the Mongoose routing systems to determine somebody is writing information that has this information in it. How do we segment this up and distribute it appropriately? So you'll select your shard keys when you're setting up a sharded environment. And this may be the last one here. Okay. All right, so now let's take a look at PyMongo. So I mentioned earlier, PyMongo is the Python library that is actually supported by Tenjin. Well, actually, they're now MongoDB Inc. They were called Tenjin previously. But they support this library. So you may see a few other ones out there that you could choose from if you're wanting to use MongoDB in your Python applications. PyMongo is the way to go, without a doubt. So let's take a look at some of the aspects of PyMongo here. this will ever change slides for me. There we go. Twice. There we go. Okay. So here's just a real simple code block. If you're wanting to get started with Mongo, let's say you have an instance up and running somewhere. You were using Object Rocket. If you're using just something that you find on just some hosting platform somewhere. Basically, you're going to have your connect string. So first thing, of course, is you're going to pip install Mongo. Make sure it's in your requirements file for your application. You're going to import it in your code like you would with any other Python library. You'll pass in your connection string. So this is going to look similar to how you would use a SQL database, whether it's Postgres, MySQL, anything like that. Very, very similar URL, except this one is prefixed with MongoDB. And if you're using secure connection, which you definitely should, if the information is going over public internet, you can pass that in as well. And then from that point forward, it's as simple as these last lines. You want to throw in a new document into a particular collection. It's as simple as that. So it's very easy to get up and running with. Okay, so I mentioned earlier that probably the biggest difficulty that people run into when they're trying to use MongoDB with Python is because it's a dynamic schema. They'll say, or they'll just neglect to actually use any sort of schema enforcement. Cerberus is a Python package that I've come to like quite a bit. Basically, it's a way for you to validate your documents before you send them into your database. And one of the nice things about it is you can define your schemas with a pretty, you see the user schema right here that I have defined. I don't think that there's any sort of class system that you can use, like how you would do it with Django, for example, but you basically define a schema just using regular Python dictionaries. You can see there are a few options here. So let's say the first name field. You want to make sure that any document that you try to put into the users collection, you want to make sure that it has a first name. You want to make sure that it has a last name, and that's going to be of type string, so that's stored appropriately in the database. And then, for company, you can do something like, okay, this one could be there, but it's not necessarily required. Also has to be a string. With business unit, you say this isn't required, but if it does appear there, let's make sure that company also exists, that the company field is also given. So it's got some nice things that you can do with that. And then basically, you could break something like this up in your code however you wanted to, but you would define a schema, and then you would build a validator using the Cerberus validator class, feed it the schema, and then whenever you want to validate a document, maybe right before you insert it into your collection, you just pass your document to the validator, and it actually just returns true or false. So it's up to you if you want to insert it no matter what, or you can take a look at the errors and say, hey, do I want to raise an exception here? If you're using an API system, you'll maybe take those errors, serialize them, and send them back in an HTTP response. Something like that. It really depends on your use case. But you can see, once again, it's pretty dynamic and fairly straightforward to use. So I highly recommend Cerberus for the schema definitions and schema enforcement and such. Let's see if we have any success going to the next slide. Great. So one of the more common things that you're going to do with MongoDB is you're going to put indexes on your data. Let's say you have some collection and it has a huge amount of data. Let's say it's like performance statistics, something like that. And you'll want to index that data very quickly. You want to be able to ensure that when your API goes and queries your database, that you're actually able to get very fast response times, right? And so that's achieved through indexing, basically, so you don't have to do full table scans or collection scans in this case. In order to retrieve data, you can use indexing significantly faster. And so let's just take a look at essentially how you would do something like that in PyMongo. So you have your user schema definition here. This is some of the server stuff that we were looking at earlier. For users collection, you basically just want to make sure, hey, if somebody's signing up for my service, whatever, I want to ensure that they provide me with a username and an email, right? Pretty straightforward, very simple requirements for somebody to provide. So we define it in the schema here. We say email is required, has to be of type string. And then there's a regex there that's kind of flowing off the side, not really important, but you want to do some validation to make sure it's a reasonable email address. And then also with username, it's required and can't be an empty string. Right? So we've got some baseline validation in place there. And then what we're going to do is, you see where we say users is equal to client.mycompany.users. So the client is going to be the PyMongo connection to your instance. And my company is going to be basically the database. So for any given, this is the same with pretty much any other relational database as well. Is when you have the system running, you can have multiple databases, and then those databases have lots of tables in them, et cetera. So what we're doing is we're using the My Company database and then the users collection. And if you want to ensure that there's an index with a unique constraint on the email field, then it's as simple as passing in these arguments to ensure index. And what this will do is it will ensure that you don't have people signing up with the same username, the same email. If they attempt to, it's actually enforced on the database level. It will raise an exception, and the PyMongo client will also raise that exception so that you don't get duplicate data, essentially. And then what we would do here, so just kind of stepping through this stuff, we insert a document, email, test@test.com, username to dot. That would go in just fine. If you try to insert the second document with the same email, what you would get is PyMongo would raise the duplicate key error. And so it's up to you on pretty much how you want to handle that in your code. So that's essentially how you would create indexes using PyMongo. All right, now let's get into the unit testing part. So I'm pretty passionate about unit testing, as you can see here, with the company that I'm with right now. When I started, the testing environment was negligible, to say the least, and that was something that was really kind of frustrating for me, because when you don't have the unit testing in place, it's very difficult to move at a high speed. You can make changes, introduce huge numbers of regressions. It's just not a fun situation to deal with. So when it comes to any of the code that you're writing, I always recommend having some unit testing in place, even if it's just for happy path testing. So let's just let's discuss a little bit of theory about unit testing. A lot of developers that I talk to, even some people that I've worked with in the past, they're like, dude, what's the deal with testing? I don't really know, like, what's the difference between unit testing and functional testing, or like integration testing, things like that. So unit testing, I actually don't think I have it written here, but unit testing is essentially a way of testing the most granular units of code that you're dealing with. So maybe that's just a function. Maybe it's just a couple lines of code that you have. Typically, it's going to be something like a function or a method. And you will test it in complete isolation, ideally. All external dependencies are mocked, they're stubbed, something like that. So you're not having to make network calls in your unit testing, or you're not having to query databases in your test run, right? So, and some of these items are, some people are like, well, in unit tests, maybe you can actually make queries to a database or write information to a database. So I know in Django, for example, I don't currently use Django, but the default unit testing platform, I believe, has like a SQLite database. Anybody in here use Django? Like unit testing in Django and stuff? Like, is there a SQLite database that uses by default, something like that?
Yeah, it does. It creates its own test database. And right now, 1.7, there's a big problem because of the way they implement migrations. The unit testing on it, if you have a lot of migrations, it's not a quick experience. Problem.
Yeah, I would imagine so. Yeah, so I guess I'm somewhat of a unit testing purist. With a lot of the tools that are available in the Python community, it's very easy to mock and patch database interfaces. So it's something that I definitely am a proponent of. So when you're writing your tests and when you're writing your code in general, these are just a few things from my years of experience that that I think are important. Testability is super important when you're writing your code. You definitely want to be thinking about, is this code testable? Or is somebody going to look at this and be like, how the hell am I supposed to test this, right? So parameterization is something that is extremely beneficial to writing testable code. And what I mean by that is, instead of mutating class state inside of your functions or your methods or something like that, favor passing in those items that are actually supposed to be mutated or which are part of an operation or something. Pass those in, and then in a test run, you can just pass in mock data instead of having to patch an item on a class, for example. So I know some of those ideas are a little far out, but hopefully everybody's able to follow along. So consider testability. Let's see. Also, another thing that I think is very important about testing is that tests don't just assert that your code works properly, but it also helps guard against regressions. So if you have a body of tests, let's say you have a library, you have 50% test coverage, that's definitely not the greatest in the world, but it's better than nothing. And what you have is, if you have a module that's very well tested, you can make changes at the speed of light, and hey, if I've broken anything, I just run the test suite and I'll see what's broken. So, tests give you an amount of confidence to actually write good code and be able to mutate things, change things, without being concerned about introducing regressions and things of that nature. Also, if you guys are into the various PEPs, PEP 8, things of that nature, one of the things that I think it's actually PEP 2, somebody can tell me out if they remember the reference, but explicit over implicit is one of the kind of the guiding lines of writing Python, right? I believe it was Keto von Rossum that's probably put that there. I'm not sure, but that's something that I also think is of great value. And so this is just kind of like a little plug towards functional programming. How many of you would say that you, currently where you're at, the code that you write, you pretty much exclusively functional programming, as opposed to object-oriented programming as pure form of doing things? Okay, so basically, the way this is actually pulled directly from, this is fun. This is actually pulled directly from Wikipedia. This quote down here on the right about functional programming. So functional programming as a programming paradigm style of building structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state of mutable data. And so I've observed just in the code that I've written over the last 5 years, I've written a lot of tests as well. This kind of adhering to this principle is, in my opinion, contributes quite a lot to unit testing in general, writing testable code. Let's see if we can go to the next slide. Okay. So just kind of like comparing and contrasting between different world views on unit testing, how it works. I break this up between ninjas and farmers, right? So if you're a ninja tester, all of your network dependencies are going to be mocked and stuff. If you have a library that's making API calls to AWS or maybe Rackspace or any other sort of API calls, patch that stuff, mock it, make sure that your unit tests are not actually invoking a bunch of network calls. It's going to slow down your test suite, and you're going to get inconsistent results when you run your test potentially. So I think that's an important part. All backend systems interfacing with databases, reads, writes, anything of that nature. If you're kind of really a unit test purist, you'll mock those things as well. And also, when you're really trying to write good test coverage, all of the different aspects of a test, any given block of code, you're going to test the happy path, which is function X is supposed to do this and that, but you're also going to test failure conditions. You're going to write tests that assert, hey, If I feed it an incorrect data type and it barks because it's like, oh, can't access an attribute on none type or something like that, test that. If that's something that may actually come up in standard, in the standard flow of logic, test it. Because then that situation is taken care of. If you're just a farmer tester, you're not as concerned about the unit testing, taking it all the way, kind of leveraging it as much as possible. I've seen things where, for example, in setting up a development environment, sometimes people for the unit tests, they'll just make sure that the dev setup is run first, and then they'll run a bunch of tests against that. And that's nightmarish in my opinion, because then there's no way to assert that the environment is in the same exact state that it was in previously. So I've seen things of that nature. Also, like we mentioned with Django, sometimes you'll use a very lightweight database, like a SQLite database, just so you're actually interfacing with the database in your unit test. This is actually something I'm not super hardline on. I know there's lots of different opinions out there. So do what is right, in your situation, definitely. But in my opinion, it should be mocked. It makes testing easier. If you're, I think that there are other types of tests as well, functional tests, things of that nature. That's when you would actually use a live database. And so with the very kind of low-level testing, you might just test half pass at best. Maybe there's no testing at all. So that's kind of a comparison, contrasting between those different approaches. So my tools of choice, particularly for working with PyMongo, but also just unit testing in general with pretty much all of the Python code that I write. I say unit test.mock here, but if you're using Python 2.7, which actually that's what my team is using currently, you're going to have to import the mock library. But my tools of choice are PyTest and the unit test mock library. PyTest is basically a library that, let's see, I'm sure a lot of you, how many of you have used Tox before? Something like a test run or something like that. Okay, so the same guy or the same group that created Tox actually created PyTest as well. And Tox seems to be a community standard. Everywhere I look, people are using Tox and using Python. Some of the nice things about PyTest, we'll take a look at some of this stuff as we go forward. PyTest doesn't use the standard unit test library like assert equals, where it's like, kind of cap case, looks like JavaScript or Java, something like that. Just uses the assert statement. Basically, any assertions that you make, you just use the built-in assert statement. Kind of does some overloading, so you get some nice error reporting. Once again, we'll take a look at some of that later. One of my favorite features of PyTest is it does dependency injection. So if you define a test, you say, I need a couple of fixtures, right? I need some mock data, and I also need, like a mocked library for making API calls. You define those, you say, these are what I need for this test. You just define them as parameters in your function. We'll take a look at a couple in a second. But PyTest will actually inject those fixtures automatically when the test is run. And it does that by just, it's some low-level, Python overloading, basically. I haven't actually looked at the implementation, just read a little bit about it, but it's a very nice feature in my opinion. It can actually be used to run tests if you've written your tests in nodes or just standard unit tests. It can be used to invoke that stuff as well. And of all of the frameworks that I've used, it's the most flexible. You can do the most stuff with it. It's the most straightforward in my opinion. And then unit test mock, I said here, it's the shit. I'm not sure how many of you guys have used the mock library's patch function before. I mean, what do you guys think about it? Do you like it? It's pretty awesome. Yeah, I think it's really good. It's saved me quite a few times, so it's really cool. Very flexible. Like I said, patching in the auto-specking feature is super awesome. Let's see, so it helps you to mock external dependencies, like I've mentioned a few times, APIs, databases, things of that nature. Okay. So here's a couple examples of using PyTest. So basically, the very top code block here, What you do is, I didn't include this because everybody knows, you would import the PyTest library, right? You define a decorator over a particular function, PyTest.fixture, and this defines a fixture for the entire scope of test suites. So basically, if the interpreter hits that module, it will register as a fixture to be injected for your tests. And so we have stub data 0 and stub data 1, right? All they do is they insert whatever value is returned as the parameter to your tests that, that require that fixture. So for example, we have a test here, test assert is awesome. And we define, just defined the parameters that we're expecting stub data 0, stub data 1. And PyTest will automatically take those fixtures just based on the name and inject them into your test so that the test has that information available to it. And we run our assert. You'll notice that that assert is obviously going to blow up. It's actually an incorrect assertion. But just to demonstrate how PyTest kind of overloads the assert function, or the assert statement rather, is when you run that test, it's going to fail, and it's actually going to do a dictionary comparison for you and show you exactly which item is not working properly. So you're not really sacrificing any functionality when you decide to use PyTest. You get some cool perks along with it, in my opinion. So some combination examples using PyTest with the mock library. Let's say you actually want to mock your database, and you're like, how the hell do I go about doing this? This is going to take way too long. Something it could be as simple as this. So we define a fixture, mocked PyMongoDB, and obviously it's a mocked PyMongo database. And so what we do is we define a variable mocked DB connection, and using the unit test mock library, we say mock create auto spec. We pass in the spec. So this is a real object that is living, doing stuff in your code somewhere. And in this case, it's going to be the PyMongo database object. And it will create a mock object that like exactly replicates what that object looks like. And spec set true means that it rigidly confines access to that object. So you can't access attributes that aren't there. It's like you're dealing with a real object, right? And then we just return that mocked DB connection. Very similar with the next fixture, the mocked PyMongo collection. That's essentially the same thing, except in this case, we're mocking the collection object. And then how you might use that in a test. Let's say you want to assert that a function, maybe some of the code that we were looking at a little bit earlier, when you go to create a user's document, a new user's entry, somebody signs up in your, in your web portal, something like that. You want to make sure that you actually get those indexes created, or at least that those calls are made. And this is a way that you would do it. I always break up my tests. You'll notice the assemble action assert blocks. This isn't actually something I do all the time, but just for the sake of clarity. The PyTest library and most of the Python frameworks that I've used for testing follow the AAA method, assemble action assert. Basically, you do some assembly on your code, set up your whatever fixtures you need, you take an action, and then you assert that expected outcomes actually took place. And so what we do here, we just have a few items. Index 0, index 1, we're expecting these to be created. Then we actually take an action. My system dot system under test, whatever that may be in your code, and then we would pass in the mocked PyMongo database, and then we just assert that whatever methods were called on that database. And in this case, it's going to be, we want to make sure it was called twice, and we also want to make sure that the expected indexes with a unique constraint were actually created. Okay, so before I conclude, we can take a look at some code real quick. So let me just go over here to my laptop real fast. Once again, before I go any further, if you guys would just kind of give me some ratings. You can even create an issue in the repo if you would like to, but go to github.com/thedodpresentations, and it's actually the only one there currently, but you can check that out and take a look at some of the code there. Let me know what you think, so on and so forth. So,
Anthony,
sir,
I have a quick question. Can you explain more about patching and auto spec?
patching and auto spec.
Mention on what it
Yeah, absolutely. Let me actually go back real quick. Okay, so is this one kind of one of the slides that you're referring to?
is. Yeah, one of the earlier ones you just mentioned is a benefit of Pro using
Yes. Yeah, I'll go back and take a look at those real quick. Let me see. Okay, so is this the one that you're talking about, Joe?
One forward.
Next one, this one right here.
Super plus plus.
Oh, Super Plus Plus?
Just exactly like, what is it and why is it so awesome for those of us that don't use the feature?
Yeah, patching and auto spec. So it's definitely Super Plus Plus. I'm just telling you that right now. So basically, the reason that I like patching and the auto spec feature when you're patching an object is that basically when you specify that there's an object that you want to patch, right? Basically, let's say you have a module, and the module is like, this is a trivial example, but something that you could do. The module is importing UUID, right? Standard library package. So what you can do is you can actually go and patch that object, any other object as well that you want, patch an entire module, and basically replace the values or return values with whatever you want. So if you want to make sure that some test function is, or rather, if you want to make sure that some function makes a call to UUID, maybe it's actually attempting to create a new UUID4, you want to make sure that it's called, and then maybe you also want to make sure that that return value is used in another section of that code. With patching, you can go ahead and patch that, and then you have exact control over what that object does. You can also do things like force it to raise an exception under certain circumstances. You can actually, like if the object is called multiple times, you can give it a series of return values. Maybe the first time it's going to return a string, and then maybe the next time it's going to raise an exception. Why the hell it would do that, I don't know, but you can do stuff like that. So the reason that I think it's great is because of how flexible it is, and that it makes patching external dependencies, like APIs or database interfacing, things like that, makes it very easy, at least in my experience anyway. So, answer your question, Joe?
Yeah.
All right, cool. So, let's see, let's actually take a look at some of this code real quick. Hopefully everybody can see that. Is that legible? Can everybody see it?
Zoom in a lot.
Yeah.
Zoom in a lot, okay. Still more?
At least one more time. There you go.
All right, cool. So, first thing we'll do, and this is actually the repository, my GitHub repository that I mentioned. I actually have this code there right now. Just as a word of caution, I wrote this stuff like right before I went to bed, a couple weeks ago, and so if it raises an exception, like don't actually use this code in production, but it demonstrates essentially how you would do this stuff. So basically, we have a real simple users module here. We have a few constants defined. This is actually a URL for a real MongoDB instance. It's running an object rocket. We'll actually make a connection to it here in a second, just so you guys can see the entire system at work. This is our database name, username and password. If I had an open access control list, you could hack into the database right now and do it, but I'm not that dumb. So, and then we, if you can see it, I'll zoom in one more time here. This is a schema that just basically defines what we want our users collection to look like. And so we have username, email, first name, last name, company, business unit, a lot of the same stuff that we looked at in some earlier slides. So no reason to linger on that. And then just a simple function here that is used to actually create a user's entry, right, in your user's collection. So to kind of go back to some of the stuff I was saying earlier, this DB, this is actually the database object, kind of favoring the whole parameterization paradigm over having like an object, and you would reference self.db and like mutate the state. This approach is significantly easier to test. Not only easier, but it's easier for other people to read the code and say, oh, that's what this person is doing. So parameterization, and then we just pass in a username, email, any other arguments are going to be tossed into the document right before it's inserted into the collection. We're going to create a couple indices here on the username and email fields, enforcing uniqueness. And then here we have the actual user's document, updating it with any keyword arguments that were passed in to the function. And then basically we do some quick validation, and as long as validation passes, that is, as long as validation doesn't raise an exception, then we just insert it into the user's collection. So pretty straightforward. You could use this code in an API right now if you wanted to. You would have some nice validation, so on and so forth. So just to highlight the validation, the validate user function, basically what we would do here is we construct a new schema validator based on the schema that we were looking at kind of at the top of the file a second ago. And then we say, if not, validator.validate. Once again, the validate method returns true or false. It doesn't raise exceptions by default. So in this case, if any problem whatsoever occurred inside of the validation process, we're going to raise an exception. So we raise the exception here, passing in whatever those errors happen to be. And then in your API framework, whether you're using Django, Flask, or anything like that, we can actually accept that exception, take the arguments from that, and then serialize that into an HTTP response, for example, if this, if you're using this in an API. And then just a couple, functions down here for actually getting it handled to the database. So let's take this for a spin real quick, and I'll have to zoom in like hell on this one as well, I'm sure. All right, so any IPython fans in here? Yeah, IPython is where it's at. Can everybody see this all right? Is syntax big enough? We'll go with it. Okay, so we're going to import the users module, right? That's the module that we were just taking a look at a second ago. And then what we want to do is we're going to say client equals users dot get client. And this is actually, you can see here, this is actually a connection to the Mongo instance that I have running in Object Rocket right now. It's using SSL. You can do something like, let's see, what is this method? It is secure? No. Is safe. Yeah, that's it. Is safe true. So is safe true, you're using transport layer security. And then to actually get connection to our database, we're going to say db equals users.get database handle, pass in the client. Once again, more testable this way. Whoop. So here we have our database object. And you can see here on the side, let me actually make this full screen for everybody. So what you have here is you can actually see we have DemoDB, so that's how you know you're actually connected to the database there. What we'll do is we'll go ahead and call the users. It's going to return the ID of the object when we insert. So we're going to go ahead and insert a document now in the database, and then we'll go take a look at it in the Object Rocket control panel so we can verify that everything worked. So we'll say users.create user. What does this look like? So we need to pass in DB, username, and email. So create user, we'll pass in the DB object that we constructed just a second ago. Just pass in my GitHub handle. And email, we're just going to do something silly like test@test.com. And that's all. We're just gonna do that. Okay, so that pretty much lightning fast, but there's our object ID. If we want to go ahead and query for that now, we can actually take the DB object and say find. This is an example. This is how you query. Instead of using SQL, you query using just basic dictionary notation like this. So we would say query where underscore ID is this object. And actually I can make that easier by giving it the underscore ID that we assigned a second ago. Oh, collection object is not callable. Sorry guys, simple mistake. But I have to see, what is this? The name of our database. Okay, the name of our database is DemoDB. Oh, it's the users collection. That's right, that's what I was doing wrong. So we want to do db.users.find, and we'll actually do find1 instead, so it just returns plain object, and there it is. That's the object. That's the item that we inserted into the Mongo database. If we try to insert another one, you can see it raises the duplicate key error that we talked about earlier. So it's, that level of granularity is actually enforced on the database based on the indexes we created. And then just says a last item. Let's go ahead and take a look at this guy here. So this is the Object Rocket control panel for the instance that we're using here. We can drill down into the database, and we can take a look at the users collection. You can see we only have one document in there, so that's definitely accurate. And here's an example schema, and this is actually the single document that we inserted there. So that's pretty much the long and the short of it, guys. Any questions for me?
Do you have some examples of when people use the MongoDB for what it's not intended to be used for?
What it's not intended to be used for, like, so basically the way that people misuse MongoDB and such.
Yeah.
I mean, the biggest one that comes to mind, I think the most common use case is people want to use it for maybe just to back their application. I mean, if you guys are into the JavaScript world at all, super big community, Node.js, basically JavaScript golden age, the mean stack, right? Mean stack is super popular these days. And so people want to be able to back their application with Mongo. And one of the biggest things that people might do that they shouldn't do is no schema enforcement. They're not using something like Mongoose in the JavaScript world to actually enforce their schema when they're interfacing with their database and such. That's the biggest one. Maybe some other use cases is, in Mongo you can store binary data if you want to, like you can store an image if you need to. There's absolutely no reason to do that. If you want to do something like that, use like Rackspace Cloud Files, use AWS service, use something else. Don't use Mongo for something like that, in my opinion.
Sorry, what's the consequence of that? Do you just need to parse table, or?
Yeah, one of the interesting, this is kind of more an operational aspect of running MongoDB, but the way that MongoDB stores data is it uses extents. So it will basically delegate a certain amount of, it will designate a certain amount of space to be used for information that needs to be stored, right? And it stores these in a whole bunch of different extents. But whenever anything changes in those documents have to be shuffled around. Sometimes the amount of memory that's being used in that extent is just shrunken. And so what happens is you have an extent for X amount of space, but only a small amount of that space is actually being used. And so it causes a very large amount of fragmentation. So if you're using like a cloud provider or your Mongo system and you're like, damn it, I know I'm only using a gig of space, why does it say I have 3 gigs of space being used? It can be because of reasons like that. And using it for things like that, trying to store binary, just random unstructured objects, can lead to more fragmentation like that, among other things, but that's the biggest thing.
Have you used GridFS?
I'm sorry, what?
GridFS to store files?
Yeah,
So it's basically like MongoDB points to where the file ends up being stored on the file system.
Yeah, GridFS. I don't remember exactly, but doesn't that come out of the box with Mongo if you're wanting to store anything larger than 16?
Yeah. If you have plenty of files, like let's say you have a database, user database, and you want to store photos for the user, you can store pictures on the Mongo file system.
way. It's not going into your database.
Yes.
It's kind of transparent. You still use the PyMongo driver. But is also has a Python driver.
Right. So in that circumstance, it's actually just storing a reference to wherever
That's
that
right.
exists on the file system. Yeah, that's cool. I think that's. Anything else, guys?
So, do you have any strategies? I know that when you sort of parameterize things, it makes things easier. I've gotten into situations with mock specifically around having to sort of mock the whole world in order to get something done, right?
Yeah,
If you've ever tried to mock something in Django, it's kind of a pain in the ass, right?
Yeah.
So, I mean, I know what I've done to get around that before, but I'm just curious if you like got any strategies that you found to be reliable for that with CPI for that kind of.
Yeah. No, I'm actually really glad you brought that up because, so, to be sure, my earlier statement, I definitely stand by it, but I think for existing projects, it can be a pipe dream. It can be a unicorn to try to chase after something like that. Mock the world, like, even with the project that I'm working on right now, there wasn't much testing along those lines, and so really trying to iterate up to that point has been a bit difficult, especially when code is written initially, and testability is an afterthought, or it's never considered at all. In situations like that, dude, I don't know. In situations like that, like what I typically do is I just select some items, even if they're not directly related, but just something that I know is going to contribute long term, and basically just get the ball rolling on getting those items refactored, make them more testable, and then kind of do a little, basically an iterable approach to knocking things like that.
Start decomposing as much as you can.
Exactly, yeah. The decomposition of big untestable objects is definitely a strategy that I use. I'm open to other suggestions, but that's essentially what I do as well. Yeah.
What would you recommend for like migration testing? If I'm moving from a piston to the REST framework or moving from one database to another database, I want to test my entire system after I've migrated over, that I still have the same functionality and I'm still getting the same data, all the data moved over. Is there any end-to-end tool for doing that?
So is this particularly like when you're wanting to migrate all of your data in one database to another, or do you mean like migrating like an application stack to something else?
I was referring to like moving from MySQL to Postgres. Or
Gotcha. I know there are lots of tools out there for doing that. I like to. I'm real big into the operations aspect behind maintaining databases and stuff, but I'm not a DBA, so I'm not going to pretend to know what the best approach is for things like that. But I know there are resources out there. I've worked with some really good DBAs, and for them, they're like, oh yeah, you ask a DBA, they'll probably be like, hell yeah, dude, like just use this or something. But
well, that works for
unfortunately, I'm not
database,
sure.
but if I'm moving like from one library, like piston
I
to
see what
the
you're saying.
Django framework, then, and there was, especially if there's a lot of customization, like we made our own REST framework, then, if we kind of use testing, then how do we do that? So,
Yeah. No, unfortunately, like nothing major comes to mind. But that's definitely a good question. Unfortunately, I don't think I've ever been faced. Well, maybe fortunately, actually, I've never had to do that. So, but yeah, if you know, tell Tim on the train because he works at Eagle Eye, right?
Yeah.
Yeah, I heard you mention that you work at Eagle Eye, but he's a good friend of mine.
Oh.
Tell him and he can tell me. Yeah, but yeah, I don't have a good answer for you. Maybe somebody else does.
What?
When the integration test is, cover that?
That's what I would think, some sort of high-level application integration test.
Yeah, that's what my thinking was. I wanted to do something. I wanted something that was in addition to that, that would just be some kind of dumb go through all the API calls and test them. So I was just wondering. I was thinking there should be a tool that does it, but I think fine.
Yeah.
So it's the difference between auto spec and the normal mock content that forces interfaces.
Right, so that's definitely a very good question. And I'm glad that you mentioned that. I'm going to have to add this to the slide later because this is like one of the big downfalls of people that start to use mock, is that if you don't use auto spec on your mock objects, you can access attributes that don't exist, and you have no, like, you might, for example, you might do something like you might want to test that a particular object is of this value or has been called, this number of times, whatever. Or rather that an attribute exists, perhaps. And the way that mock works is that it actually, when you access the mock objects, is when it creates it according to whatever the interface is. And so you might assert that the mock object has an attribute X, but you kind of like made a typo or something like that, and it will actually say, yeah, this object exists or this attribute exists, but you made a typo, and so you're screwed at that point. But if you use autospec, it'll raise an exception and say, dude, this attribute doesn't exist. So that's why I like using the autospec feature.
Put that in there. It's a lot more descriptive than super custom.
Yeah, no. That's really that's the only issue in my repo. Install my repo. No, that's definitely a good question. Big downfall. I fought with that lots of times, dude.
Do you know if it actually goes a bit further and introspects functions and checks the number of arguments, for example?
I've never tested that. I don't think it does like call signature checking or anything like that. Just ensures that, at least in my experience with the depth that I've looked into it, I don't think it goes quite to that level. Does anybody else know? I've never used it on that level, but yeah, I don't think it does.
Maybe this is a silly question, but what advantage do you gain from the flexible schema system if you're then using something like servers to enforce a schema?
Right. So, so Cerberus doesn't act like I think I mentioned this earlier. I did. Cerberus doesn't actually enforce the schema. It just tells you whether or not it validates according to the schema. So there may be situations where you just want to ensure that certain items are there, and then you don't give a crap about any of the other fields in the document. And so the beauty of having a flexible schema, in my opinion, is that you don't have to, migrations are no longer such a big deal. That's, in my experience, that's the biggest benefit, is that you don't have the operational overhead of having to migrate your data all the time. You know what I'm saying? Especially when you're doing quick development. Mongo is great for quick development, prototyping an app, getting stuff out there. It also is great for mature apps, of course, don't get me wrong, but so using Cerberus, because it's dynamic like that, you kind of get the best of both worlds. Does that answer your question?
I just want to put out that for folks who like something more like a Django model style declaration, there's another library, which is actually maintained by one of the other organizers of the Josh Marshall. But yeah, it's kind of a declarative class-based.
That's super awesome. I've never used it before. I will look. What did you say it was called?
Mongo without an N.
Oh. I should be able to remember that.
Yeah, just type it and
All right. Well, thanks very much, guys.
All right, everybody. Well, feel free to hang out around here for a little bit longer, like maybe 15, 20 minutes, and then we're going to head, if anybody's feeling adventurous or if you want to chat some more, we're going to go out to Taco House, which is at between 6th and 7th on Trinity Street, about 2-ish blocks away from here. We tried to pick the closest place since it's cold outside. So we can hang out here for a little bit longer. There's some beer left in the back, some tacos, so help yourselves, and then we'll kind of clear out of here in 15 minutes. Thanks for coming, everybody.